Hey, this is the assignment for a YouTube video. So first we have our import statements. Then we have to mount the files that was given to us in Google Drive. To do this, I had to basically take the data.7z file, change it into a zip file, and upload that to Google Drive so that I could use it. So basically what I did in the code is just mount the Google Drive, verify that the file path work, and then down here I loaded the file path using content drive, my drive, Colab notebook, data.zip, the file path, and then I unzip the file using the zip file.zip file command, the with zip file, yeah. And then extract the files with the extract all command. So next is we move on to step 2 of the assignment, which is to just load and process the image. So we needed to have the image size is 28 and 28 by 28. And then so basically I needed a function that would load the image. So I just have def load image from folder path, and it takes this folder path that was defined. Well, it's not defined here, but it's defined later on. So then I just say for file name in os dot list directory folder path, and then image equals image dot open os path dot join path folder path. Basically, just use these in order to get the images out of the file to load and process the image. Then I'm processing the images versus just straight up um, resizing to the image size. So as you can see here, the variable I declared up here is called, and then I also can convert the image to grayscale, change them from black and white, basically doing this in order to muddy up the images so that I'm not overfitting the training data. Next, we go and use image array equals image array image img. And then finally, we return mp.array of images. After we've processed them, we process them and load them back into the array. We then return that array. So, and then next we have the train folder. So assignments, data, assignment data train, load them back. And then train images equals load images from folder, train folder, the definition. The function we defined up here, we're now calling down here. And then we're able to normalize the pixel values. So we just do that by saying train underscore image equals train underscore image dot ace type float 32 divided by 255. So next we're able to move on to step 3, which recommended that we basically save use numpy.save in order to save the file or save an X and Y arrays because it just takes so long to run the program. So we just do mp.save train image.mpy and then train images. And next we can load them. Train images.mpload train images.mpy. Finally, step 4 was another recommendations. So we are able to move on to step 5, which is just create an autoencoder. So we have this function that's create autoencoder. So we have input layer equals 28 times 28 RGB image, which has 3 channels in it. So we have our input layer underscore image. And as you see, layers with this amount of shape. Next, after this, we're able to move on to our encoder, where, as the comments, the first convolutional layer extracts the low-level features in the 32 filters that have the size of 3 times 3. So we have just x equals layers dot convo 2D, and we're able to do it. Next we just downsample using the max pooling to reduce the dimensions. Um, the second thing we need to do is make the second layer, where we're just extracting more complex features. So we just do that by saying x equals layers dot conv conv2d 64 3 comma 3 activation, and then padding. And next we even go further or downsample further and use layers dot max pooling 2d 2 comma 2, and then padding equals same. Next. Fine. The very next step after this is to just use the decoder or program the decoder. So we just go in and say first decoding convolution um, in order to compress the representation. Basically, we just say x layers equals 2D convo. It should have the same output as above. Um, Next, with this command, we just upsample the layers, as you can see here. Finally, we use a. Oh, finally, the second decoder uh, reduces the depth to 32 filters. So, as you see here, and our output is now 1414, comma 32. And then we upsample this to get the original resolution so that now our output can be 28, comma 28, comma 32. Then I have over here just some extra upsampling in order to kind of just refine all the features and such. So we just have x equals layers dot conv 2d 32 3 comma 3, and then activation and the padding sequence. And then we do this one more time, and I have x equals layers dot upsampling 2d. Moving on to the output layer, we just need to write decoded equals layers dot conv 2d 3 3, and then 3 comma 3 activation sigmoid, program the sigmoid and the padding. Finally, we can just build the auto coder model by just saying auto encoder equals model dot model or models dot model using the image input image variable and the decoded variable that we defined up here. Next is then finally we can compile the model and have the atom optimizer and mean squared error loss, and just do that by autocoder dot compile, and then set the optimizer to atom and the loss to mean squared error, and then finally return the autocoder. And then so next thing we need to do is just as you see in the comments, just create an autocoder and print the summary of the architecture. So autocode, we define the autoencoder and then do autocoder.summary for the display the layers. And here is the output of the code. By the way, I need to screenshot that. So as you can see, we have the layer, all the different types of layers, and then we have the output shape, and then we have the parameters in each layer. And you can see the total parameters and trainable parameters and the non-trainable parameters here. So next, moving on, I believe, yeah, that was step 5. Next, moving on, we just need to reshape the training images to include the channel dimensions. And as you see in the comments, we do this to ensure that the input matches what the model expects it to be, or the input size and shape matches what the model expects. So we just have train images equals train images dot reshape. We have -1, 28, 28, and 3. Finally, we need to have a function to resize input images to 56 times 56 resolution in order to create the target outputs for the encoder to learn to reconstruct. So we just do that by saying, defining our function. So I did resize image to 56 images and right, and using TensorFlow, resizing to upscale the images, I just say resize underscore images equals TF TensorFlow dot image dot resize, and then the desired resolution I want them to be, and then I just return the resized images variable. Then I need to generate the target high resolution images um, that we use during the training. So I just do that by saying train images target, defining that variable and setting it equal to resize image, calling this function down to here and using the train images variable as a parameter. Next, is next I just need to you have this code here down to in order to debug it. So just print uh type train images and then print type train images target and then print the shapes of the image data set. So print, it just prints this stuff down here so I can see what the code is doing and debug it if necessary. Finally, step 6 is basically just training the model. So I just do that by saying autoencoder.fit and train image, and I use the train image to target, use 20 epochs with a batch size of 64 and a validation split of 0.1. And then I save the model by saying autoencoder.save models chars. And as you see here, the epochs are running, and you can see the loss values over here. Finally, we use the given code that was given to us in the assignment in order to actually print um, the what's it called? Print and plot the original images that are the original images and their generated and altered versions that we use to muddy up the code, to muddy up the training data so the AI model has more stuff to train off of and to improve off of. So, and as you see here, this is the result from running this program. So we have these 3 different images. One's real small, one's blurry, and one is the original resolution. Yeah, that's for all of them. All right, well, this concludes the assignment 3 recording.